This is Mr. White.
And Mr. Rops.
We're going to show you the last topic in our integral calculus unit, volumes of revolution. So it's sort of a pretty easy idea, although it looks very complicated. But basically, if we take this is a radius of a circle. Well, this is the length of our function, so this length is f of x. And if I revolve this entire length around x, around the x-axis, then I have a length always of f of x.
Well, and that's always the same radius all the time.
All the time, everywhere. So the area of this circle, right here is
pi r squared, of course.
Pi r squared. Area of a circle is pi r squared, but area of this circle.
Oh, r is going to be just whatever that f of x value is.
F of x squared. So f of b, I guess, right? F of b.
F of b, right? Because we know what that value actually is for that specific one right there.
So basically, what is happening is we're taking a circle. In fact, infinitely many of them, and we just multiply it by how long our interval is. So we can take a little peek here, sort of a demonstration.
So just to make sure, so we're going to take this curve and rotate it all the way around the axis.
Yeah.
And when we do that, we're going to get some kind of solid shape.
Correct.
And that's what we're looking to see. Oh, look at this nice graphic.
Yeah, so we can actually look at it. So we basically are taking f of x, you see the y value here, and we're making a circle out of it.
Nice.
Okay, so let's get it back to the original, or something like that. Okay, so the cross section, you can see it like that, moving left and right there. Those are all just circles.
Right, they're changing circles.
Yeah, and the radius is always f of x.
Right, and those circles are changing over interval. I feel calculus is going to be coming in when it comes.
Yeah, so here's the radius, f of x. Area of a circle is pi f of x squared, and then the volume is just how long it is, which is a to b.
So basically, we take all those circles and add up all those circle pieces from a to b.
Yeah. So the volume of a cylinder is just pi r squared times how high it is. Well, in this case, it's pi r squared times how long it is, because we just sort of imagine it's on its side. So it's integral of a to b of pi r squared. That's it.
And that is the h.
So let's go ahead and do one.
Okay, great.
So we have this quadratic, x squared plus 3. We're going to revolve it around the x-axis and find the volume from 1 to 2. So pi, we'll bring the pi out front. How about that?
Oh, good, because it's constant, and good Lord, it's going to be confusing enough with all the signs and negatives and stuff. So
pi r squared, that's it. So I know what some of you are thinking. You're going to want to go, okay, 1/3 x squared plus 3 cubed. Well, that ain't it. So here's a little tip. If this is ever anything but a linear piece, like an mx plus b, it's not what I just said. So we'll come over here, and we'll go x squared plus 3, x squared plus 3, x to the 4th, plus 3x squared plus 3x squared is 6x squared plus 9. This will be a much easier integral to take.
Oh, good.
Pi 1 to 2, x to the 4th plus 6x squared plus 9 dx. All right, Mr. Ops, take over.
All right, so we got the pi there, and we're going to take the integral, so we're going to go 1/5 x to the 5th, or 1/5 x to the 5th.
Yeah.
Plus 2x cubed.
Oh, 3?
3, yes. I'm doing
no,
bad.
2x cubed.
2x cubed. The 3's got to come up top.
Yeah.
Plus 9x.
9x. All evaluated from 1 to 2.
Perfect.
Okay, notice the notation here. We have an integral sign here before we take the integral, and then we take the integral, and we have this vertical line here from 1 to 2. It's very important that you remember that notation. I've seen some nasty things out there. Okay, so pi.
Let's keep that out at the front forever.
Yeah, let's do that forever. So pi.
Plug in our 2, 1/5.
That's 32 over 5. Plus 2 cubed is 8 times 2 is 16 plus 18.
Yep.
Minus
1/5.
1/5 plus 2 plus 9. Okay, so let's start doing some calculator stuff here.
All right, let me
16 times 5.
80,
So 32 plus 80 plus 18 times 5.
90.
Whole thing? No.
So 80 plus 90 plus 32 is 202 over 5.
Okay. Minus. That's 10 plus 18, 28, 29
29 fifths
over 5.
minus 29. 173 over 5
Pi.
pi.
So that's the volume. Wait, what's the units? Units
Oh, its volume got to be cubed then.
cubed. Got cubes. All right, there you go.
Wonderful.
Stay tuned we'll do another example after this.